Can fine-tuning LLMs cause catastrophic forgetting? Imagine teaching a robot to cook a new dish, and suddenly it forgets how to boil water. That's similar to what happens when we fine-tune large language models, and they forget what they already knew. Fine-tuning is a way to make these models better at specific tasks by training them further on new data. But sometimes, this process can cause what is called catastrophic forgetting. That's when the model loses or weakens its previous knowledge because it adjusts its internal settings to perform well on the new task. This is a common issue in machine learning, especially with neural networks like large language models. When a model is fine-tuned for a particular job, like answering questions about a specific company, it might get really good at that but forget how to handle general questions. For example, if a model is trained to answer questions about a bank, it might start giving wrong answers about unrelated topics. This happens because the model's parameters, which are like its internal dials, change to fit the new data, sometimes at the cost of what it already learned. Larger models, those with billions of parameters, can actually experience more severe forgetting. This is because they start with a lot of knowledge, and when they are fine-tuned, their extensive understanding can be more easily disrupted. Interestingly, the architecture of the model also plays a role. For instance, models that are decoder-only tend to forget less than encoder-decoder models during fine-tuning. To prevent this problem, researchers have come up with clever techniques. One method is called Low-Rank Adaptation, or LoRA. It fine-tunes only a small part of the model, leaving most of its original knowledge untouched. This way, the model can learn new tasks without losing what it already knows. Another approach is called elastic weight consolidation, which helps the model remember important parts of its old knowledge while learning new things. There are also other strategies like gradient episodic memory and brain-inspired replay, which involve replaying old data to remind the model of what it has learned before. Sometimes, doing general training before fine-tuning on specific tasks can help the model keep its broad understanding. This is called instruction tuning. It makes the model more stable and less likely to forget. In real-world applications like chatbots or virtual assistants, balancing new knowledge with existing skills is key. If a model forgets too much, it can give inconsistent or incorrect answers. That's why choosing the right fine-tuning method and using these techniques is so important. It helps keep the model sharp across many tasks, making it more reliable and useful for everyone.